He'd been insulating homes for 18 years, crawling through attics and basements, sealing air leaks, helping families reduce their energy bills. Just another elderly worker trying to supplement his retirement income, until a massive energy crisis threatened to leave thousands without heat during the worst winter in decades. And suddenly, the quiet weatherization worker revealed why he understood thermal systems that stumped government engineers. Vernon Eugene Matthews was 77 years old, with thinning gray hair that always seemed dusty from attic work, and intelligent brown eyes that could identify heat loss patterns invisible to most people. His weathered hands moved with practiced efficiency despite arthritis, installing insulation and sealing air leaks with tolerances that ensured maximum energy efficiency, while his voice carried the patient teaching tone of someone who understood that proper thermal protection could mean the difference between comfort and hardship for families on limited budgets. Welcome to the Human Stories. Before we continue this incredible tale of hidden expertise and life-saving thermal knowledge, tell me in the comments what city you're watching from today. And if you believe stories about quiet masters deserve to be heard, hit that subscribe button. The Northern Minnesota Weatherization Assistance Program operated from a modest office building in Duluth, where federal funding helped low-income families improve their home's energy efficiency through professional insulation installation, air sealing, and heating system improvements. The program served rural communities where harsh winters could make inadequate insulation a matter of survival rather than mere comfort. Vernon had worked for the program for 18 years, providing weatherization services that transformed drafty, expensive-to-heat houses into comfortable, energy-efficient homes. His work involved comprehensive thermal analysis of building envelopes, identification of heat loss pathways, and systematic installation of insulation and air sealing measures that could reduce heating costs by 30 to 50% while dramatically improving indoor comfort. His approach to weatherization combined technical precision with patient explanation, helping homeowners understand building science principles that would help them maintain energy efficiency long after the installation work was completed. Mrs. Anderson, the reason your upstairs bedrooms are so cold isn't just insufficient insulation. You've got significant air leakage around the electrical outlets and where the walls meet the ceiling. Cold air is infiltrating through those gaps and creating convection currents that make insulation less effective. These educational consultations represented more than routine energy efficiency work. They were informal building science seminars that helped families understand how heat transfer, air movement, and moisture control interacted to determine both comfort and energy costs. The weatherization program management appreciated Vernon's expertise and thoroughness. His installations consistently exceeded performance specifications, his diagnostic assessments identified problems that other workers missed, and his patient teaching style helped families understand how to maintain the improvements he implemented. What none of them realized was that Dr. Vernon Matthews had spent 39 years developing thermal systems with expertise that made residential insulation work look elementary by comparison. Vernon lived alone in a well-insulated farmhouse 20 minutes from Duluth, a structure he had personally retrofitted to demonstrate advanced building science principles. The house was comfortable year-round despite Minnesota's extreme weather, maintained at precise temperatures using minimal energy through thermal design that incorporated technologies most residential builders had never seen. But the basement workshop revealed technical capabilities that exceeded weatherization worker requirements. The walls displayed engineering diagrams and research documentation spanning nearly 4 decades of thermal systems development, insulation technologies that had improved energy efficiency in commercial buildings, thermal barrier systems that had protected industrial equipment from extreme temperatures, and building science research that had established the energy codes currently governing residential construction. Bookshelves held technical references that most building scientists would consider graduate-level material, thermodynamics text, heat transfer calculation manuals, and moisture control research that Vernon had contributed to during his academic career. Filing cabinets contained project documentation for thermal systems that had affected energy efficiency standards throughout the northern United States, And in a secure drawer that seemed unnecessary for weatherization work were credentials that would have transformed how Minnesota's building science community viewed their rural insulation worker. A Ph.D. in mechanical engineering from the University of Minnesota, emeritus professor status from the Department of Thermal Sciences, and consulting agreements with the Department of Energy that had shaped how America approached building energy efficiency. Dr. Vernon Eugene Matthews, internationally recognized expert in thermal systems engineering and building energy efficiency. His academic career had focused on understanding how heat transfer occurred through building envelopes, developing insulation technologies that provided maximum thermal protection with minimal environmental impact, and establishing building science principles that balanced energy efficiency with indoor air quality and structural durability. The work had taken Vernon from laboratory research that advanced understanding of thermal physics to field applications where his designs improved energy efficiency in everything from single-family homes to industrial facilities. His expertise had been crucial in developing the energy codes, insulation standards, and weatherization protocols that governed how American buildings were designed to minimize energy consumption. Retirement in 2006 had been voluntary, rather than mandatory. Vernon had accumulated enough academic tenure to retire with full pension while still young enough to pursue hands-on work that didn't involve the publication pressures and administrative responsibilities that had characterized his university career. The weatherization position wasn't about financial necessity. His university pension provided adequate retirement income. It was about applying thermal engineering knowledge directly to helping individual families rather than developing academic theory, using building science skills to serve people who couldn't afford expensive energy efficiency improvements, and continuing the thermal protection mission that had defined his professional life. But 39 years of thermal systems expertise doesn't disappear because someone changes from university research to residential insulation work. And Vernon's trained eye continued monitoring building performance issues that could affect entire communities when energy systems failed during extreme weather. Monday, January 14th, started with weather forecasts that predicted the worst winter storm system in Minnesota history. Vernon arrived at the weatherization office at 7:30 a.m., reviewed emergency protocols for severe weather, and prepared for what meteorologists warned could be life-threatening cold temperatures affecting the region for over a week. The storm system wasn't just bringing extreme cold, it was creating conditions that would strain energy infrastructure beyond its design limits. Natural gas systems, electrical grids, and heating equipment were about to face thermal loads that exceeded anything Minnesota utilities had planned for, while families in inadequately insulated homes would face energy costs that could force impossible choices between heating and other necessities. At 2:30 p.m., Vernon received a call that triggered 39 years of thermal emergency response experience. The regional utility company was experiencing cascading failures in natural gas distribution systems, caused by extreme cold that exceeded design specifications for pipeline equipment and pressure regulation systems. Thousands of homes were losing heating capability just as outdoor temperatures dropped to levels that could cause hypothermia within hours. Dr. Matthews recognized the emergency immediately. Widespread thermal system failure during conditions where inadequate building thermal protection could result in mass casualties from exposure. Vernon, this is dispatch. We're getting emergency calls from families whose heating systems are failing, and the utility company says it could be days before service is restored. They're asking for emergency shelter recommendations, but the community centers don't have capacity for everyone who might need help. Dr. Vernon Matthews faced a choice that would define his impact on community survival. He could work within his weatherization technician position, providing standard emergency advice, while hoping that government emergency management would develop effective thermal protection strategies before people experienced life-threatening exposure. Or he could use 39 years of expertise in thermal systems engineering to implement emergency heating solutions that went beyond standard winterization, drawing upon knowledge that could save lives if applied quickly enough. Vernon made his decision in approximately 20 seconds. Dispatch, this is Dr. Vernon Matthews, thermal systems engineer.
I'm implementing emergency thermal protection protocols for affected families. We can provide temporary heating solutions using building science principles that will maintain life safety temperatures until utility service is restored. Over the next 14 hours, Vernon coordinated thermal emergency response that kept vulnerable families safe during infrastructure failure that could have caused numerous cold-related fatalities. He established emergency heating strategies using passive solar heat gain, thermal mass, and emergency insulation techniques that maintained habitable temperatures without functioning heating systems.
His weatherization experience provided intimate knowledge of which homes in the region had adequate thermal protection and which families would need immediate assistance to survive extended periods without utility heating. Dr. Matthews, this is emergency management. We understand you've been coordinating thermal protection for families affected by the heating system failures. What's your background in building thermal systems? Vernon looked around the emergency coordination center that had been established in the weatherization office, where his thermal engineering expertise was now managing survival strategies for thousands of people. Emergency management, this is Dr. Matthews. I've spent 39 years designing thermal systems that keep buildings habitable under extreme conditions. These emergency heating strategies are based on building science principles I've been researching for 4 decades. The thermal protection strategies that Vernon implemented during the emergency saved an estimated 47 lives during what became known as the Minnesota thermal crisis of 2024. His emergency insulation techniques, passive heating methods, and thermal conservation protocols provided the knowledge base that kept families safe until utility services could be restored. The story made building science publications as an example of how advanced thermal engineering could be adapted for emergency response, but most coverage focused on community resilience rather than the academic expertise that had made such coordination possible. Vernon returned to his regular weatherization duties, insulating homes with the same methodical precision that had characterized his pre-emergency work. But something had changed in his relationship with the building science community and his understanding of how his expertise could continue serving thermal protection. "Vernon, thank you for the emergency heating advice," said Mrs. Peterson, whose family had survived 3 days without utility heating using thermal conservation techniques Vernon had taught them. "How did you know so much about keeping houses warm without furnaces?" Vernon looked around the attic space where he was installing high-performance insulation, his brown eyes holding the analytical intensity that had never quite disappeared. "Mrs. Peterson, I've been studying how buildings lose and conserve heat for most of my adult life. Whether I'm researching thermodynamics or installing insulation, the mission stays the same, keeping people warm and safe. Were you really a thermal engineer?" Vernon smiled, adjusting his weatherization program shirt that covered academic credentials he'd hoped never to need again. "I've spent my career understanding how to keep buildings energy efficient and comfortable. Now I get to apply that knowledge directly to helping individual families rather than just publishing research papers about thermal theory." Dr. Matthews continued his weatherization work until he was 84, when mobility issues finally made attic and basement work impractical. He spent his final years training emergency management personnel in thermal protection techniques that could save lives when energy infrastructure failed during extreme weather. Because he learned that the most effective thermal protection often required expertise that exceeded standard weatherization training, building science knowledge that continued regardless of job titles, and thermal engineering skills that served both individual families and community survival with equal dedication to keeping people safe when winter turned deadly.